Hello students of my 8th grade science class. I'm presenting this Explain Everything video for the benefit of those who would like to see the results of the lab involving the Crisco again as a review, and also more importantly for those students who were not there the day we actually conducted the lab. The video which will follow represents the lab in its entirety. There are some internal questions that are part of the video which we will answer along the way. For at this time, you may watch the video, and at the end of the video we will define the ideas that were to be used to revise your initial explanation and or drawing of the answer to the question, how does the air get warm? And so I'll play the video now, and it'll periodically be paused when appropriate. If you have already witnessed the lab and conducted the lab, you may fast forward to the area at the end of the video where the revised diagram will be once again illustrated. Any student that was not able to witness the entire completion of the diagram due to the loss of time and or again your absence, please focus on the completion of that diagram again towards the end of this video. Okay, so take a look at the lab that we did, and then we'll discuss and produce the diagram which represents how the air gets warm.
Four pieces of Crisco lined spaced equally on this metal bar. We're going to light our Bunsen burner. The Bunsen burner is going to heat the metal bar, and we're going to start our stopwatch. As we conduct this lab, we should be thinking about how does the components of this lab represent aspects of the Earth and the atmosphere. Oops, okay, that's at 32 seconds, the first blob fell off. So how do components of this lab mimic, or how are they a metaphor for the Earth and the Earth's atmosphere when it comes to the question, how does the air get warm? How does the air get warm on the Earth? And this lab should illustrate three aspects of that process. So think in your mind, even though these things are not visually the same, what does the Bunsen burner represent? What does the metal represent? And what does the Crisco represent? Okay, at 1 minute and 17 seconds, blob number 2 dropped.
So as the video continues, as we've paused it now, but once we continue the video, think about what does the flame represent in this video. The flame is heating the bar, and then the Crisco is responding to the heat. So is the heat from the core of the Earth, is that represented by the flame? Or does the flame represent the sunlight from the sun? Finally, is it possible that this heat comes from CO2 and the greenhouse effect? Consider the drawing here down below the video. The black line represents the surface of the Earth. Obviously, the yellow ball with the lines is the sun, and the atmosphere is represented by the blue area with the dots representing the particles of the air itself. Perhaps the heat of the flame represents heat that comes out of the inside of the Earth from the core. This idea has been proposed by students before. One might propose that the heat from the greenhouse effect is simply rattling around in the atmosphere, and that represents the heat of the flame. Of course, it's also possible that the heat of the flame is representing the sunlight that comes to the earth from the sun. If you guessed it, the heat from the core of the earth is the source of the flame's heat, you are incorrect. If you are thinking the heat from CO2 and the greenhouse effect is possibly the source of the heat of the flame, also incorrect. If you guessed the sunlight from the sun is represented by the heat of the flame, you are correct. The flame represents the heat waves or heat in the form of light from the sun.
So you might ask the question, how is it possible for the Crisco to get heated when the heat from the Bunsen burner is actually down here? What has to happen in order for, Crisco blob number 3 dropped at 2 minutes and 20 seconds. What has to happen for the Crisco to melt and fall off the metal bar?
Now that we've identified that the flame of the Bunsen burner is representing sunlight from the sun, what would the metal represent? Remember, the Bunsen burner flame is heating the metal. Although the sun from its interior does heat the surface of the sun, that is not the correct answer for this context. In this context, we're asking, how does the air on the earth get warmed? In the diagram, you can see the sunlight passes through the atmosphere and then strikes the earth's surface. Is it possible that the air absorbs the sunlight energy as the sun rays pass through it? If it was possible for the air to directly absorb the energy in sunlight, it would need to absorb the light itself. And since the air is mainly transparent, allowing the sunlight to pass through it freely, reaching the surface of the earth, the air does not represent the metal. Therefore, the surface of the earth is represented by the metal. The sunlight reaches completely through the atmosphere, strikes the earth, and the energy from the sunlight is absorbed at the surface of the earth. Therefore, the sunlight is actually heating the surface of the earth, just the same as the Bunsen burner flame is directly heating the metal bar. Finally, what does a Crisco, the white blobs, represent in the lab? Quite possibly, they might be the planets. It wouldn't be unusual for someone to attempt that as a possibility, but this question deals strictly with what's taking place on the Earth. So the planets would not be a good choice. They look like planets with the sun at one end, but that is not the context of this question. Since we've already identified the metal represents the surface of the earth, which is being heated by the flame, the sunlight, the Crisco must represent the air. And the Crisco, or the air, is being heated by the bar, which is representing the surface of the earth. As the sunlight from the sun strikes the earth, a small bit of it might be reflected back out of the atmosphere but a large and main component of it actually stops and is absorbed by the Earth. This heats the Earth up, and the heat from the Earth would then heat the atmosphere, since the atmosphere is actually touching the surface of the Earth, just as the Crisco is touching the surface of the metal. When heat is passed from one object or substance to another because they are touching, the process is known as conduction. The air is heated by conduction with the earth. The earth heats the air through the process of conduction.
Crisco blob number 4, dropping at 3 minutes and 52 seconds. So now we'll clean up the lab, and we're going to try and piece together the components of the slab together with our thinking on how does the air get warm given this type of lab setup and the components in the slab. We're going to apply them to that question in the diagram.
Let's review some ideas for the diagram revision that we can take from the lab experience. First, we know that the flame of the Bunsen burner equals the sunlight from the sun. Second, we know that the metal equals the Earth's surface, which is heated by the flame. Third, we know that the Crisco represents the air, which is heated through conduction by the Earth. Given the lab experience and the components of the lab, we should now know that the Earth is heated by sunlight that passes through the atmosphere first. The heated Earth surface heats the air by conduction. The last idea we want to include on this set of revision ideas involves what happens to the air when it becomes heated. How does the air respond when it becomes heated? What happens to the air? It's easy to understand when you think about a balloon. A balloon will start out at a given size, but when it's heated, the balloon will increase its volume. We say the air expands. How is it that the small balloon can increase in size to the large balloon, given the fact that the number of molecules of air within the balloon itself does not change? So the number of air molecules in the small balloon is still the same number of air molecules in the large balloon, but the volume is now larger. The answer to that question is air expands when you heat it. And for the number of particles to remain the same, the only way expansion can take place is if the particles literally move farther apart. Therefore, heated air is represented by particles of air which are now farther apart. So we'll add that in as our final note for the revision of the diagram. So our diagram should also include some representation of the air expanding or has expanded after being heated, and particles should be illustrated showing that they are now farther apart, which represents the heated air which technically has expanded. Let's start with a line which represents the surface of the Earth. Sunlight enters the Earth atmosphere, passing through it. In my diagram, I must include light rays that actually reach the surface of the Earth because the atmosphere is mainly transparent. to represent the air particles, since the surface is solid, the area above it is the atmosphere, I'm going to use dots, which represent the particles of air in the atmosphere, and the number of dots, or the compactness of all of these dots, is going to represent the degree at which the air is holding temperature. So if it is holding a lot of temperature, these particles would be represented as being further apart. It would represent that warmed air if they're further apart. And when we get down to the area where the sunlight has struck the Earth is going to warm, and this heat is going to radiate up out of the ground in the form of heated air. So heat from the surface is heating the air above it, and this causes the particles in the atmosphere to become more excited, and they are now further apart in my diagram, which it technically represents the heated air as it has expanded. Conduction occurs here at the surface, and that is where the heat exchange takes place. This is cooler air above the surface, far above the surface. This is warmer air nearer the surface. And let's not forget, the yellow lines represent sunlight.